Okay, here we go. Number 6 is 7. Now remember, we need to use our rules. And our rules look like this. 60 degrees, 30 degrees, 90 degrees. Alpha, 2 alpha, and alpha square root 3.
So that's
Okay?
2?
How do you know the difference between when it's a square root of 3 and a square root of 2?
Because the 30, 60, 90 has a square root of 3. Because basically a squared, b squared is c squared. Right? So this should turn into 3 alpha plus 1 alpha, which is 4 alpha. And this 2 times 2 is 2, so that's 4
So
alpha.
when it's a 45, it's a square root of 2?
Yes.
So the 30, 60, 90 rule is square root of 3 and the 45 angle is square root of 2.
Yes. Okay, so instead of using x's, I changed it to alpha because, and you get quiet, because I see a lot of our problems have x in it. Okay, so we want to change them to alpha so that we know a difference. We can see a difference. Okay, and with this, now I want to rewrite whatever this one is. I want to take the one that we're using and rewrite it. So this is a 45, 45. And this is a 45, 45. Okay? So that means I'm going to use this guy. But I need to draw it the same way this is, so that it's easy to do. When I do that, I know that this and this, I know that across from the 90-degree angle is the 2, right? The alpha square root 2. Okay? Now, I also know that because this is a half of a square, this is alpha and this is alpha. They're the same. Right? And what's nice is I know that these are the same. I know that this is equal to this. And I know that this is equal to this, so I know that this is equal to this. So therefore, y equals 7. Okay? Alpha is equal to 7. Definition of special triangles. Okay? And then, we know that y is equal to alpha. Y is equal to alpha. Definition of special triangles. Okay? And then, well, alpha is 7, so y is equal to 7. Substitution. Now you could have written this as 7 equals alpha, and then y equals alpha. And remember that formula, that rule at the beginning of the year? If a equals b and b equals c, then a equals c, right? And we could have used that rule also instead of just substitution. So we could have set this up and used, what is that rule? I forgot. I'll have to look it up. But we could have used that rule.
That one rule.
That one rule. God, what is that rule? It's on the tip of my tongue. Oh well, I look stupid now because I'm on the film trying to figure it out. If a equals b and b equals c, then a equals c.
Oh, you told us this.
Yeah, I know.
So what's alpha supposed to be? I've been lost on the alpha part.
Alpha is just a new way of writing x.
I don't like it.
It's that way. If I wrote x over here, then you would think that these x's are the same, and they're not.
Can I see?
That's why we're using something other than x.
Oh, are you saying that just because how the problem is?
Huh? The fish? It's just a fish. Just draw a fish. Okay? Alright. Now we got to figure out the last part, which is x. Now we know because of the definition of special triangles.
Wait, is it 14?
That x is equal to this. So x is equal to alpha square root 2. Right? How much is alpha?
7.
7,
Oh.
right? So that means that x is equal to 7 square root 2. Now this is because of definition of special triangles. Okay? But this is because of substitution. Okay? That's it. That's done. 7 square root 2.
Oh, wait, is this just like A2 plus B2?
It'll take a minute until I
Yes.
get to this shit.
Hey, wait till the next problem.
Yeah, if you think that's hard, this next problem's going to throw you for a freaking loop. Alright?
The only thing I heard was alpha, and then I kind of got lost.
Okay. So just remember, alpha is just another way of saying x. Okay? It's actually another way of saying A. It's the A in the Greek alphabet. Okay? But I didn't want to use an X. The X in the Greek alphabet is called Z. Z.
Yeah.
Right? And so it looks like this. And that looks like too much like X. And I didn't want to use it. You know what I'm saying?
Okay.
So what I wanted to use was something that didn't look like one of our letters. So that way if they throw an A up there, if they throw a B, if they throw... Because beta looks like this. Well, that looks like B. So I don't want to use that, right? And so, you know, there's just... I tried to just choose a letter that doesn't look like any of our letters, but you can differentiate it from the X and the Y, the A and the B, the M and an N. Okay? I'm going to pause this.